Hi, hopefully this will be a pretty quick video lesson about working with exponents that are rational, that is fraction exponents. There's three particular skills that I wanted to demonstrate for you. The first is when we have an expression that's given to us in rational exponent form, we should be able to understand that form as a radical, that is with square roots, cube roots, fourth roots, and whatever. So we call that radical form. So the number 10r to the negative 3/4 power is exponential form. To get it into radical form, I'm going to deconstruct this exponent. First one I like to get rid of is the negative exponent. Recall negative exponents mean take reciprocal, so I'm going to instead have 1 over 10r to the positive 3/4 power. And then the 3/4, remember the numerator is the root, that's the fourth root of 10r, and that's the cube. So we have two different things to do. We have 10r cubed, and we have the 1/4. So the 1/4 is the radical that I was looking for. And then I'm going to do a quick power of a product inside. We're going to get 10 cubed, you're welcome, and r cubed. And since we can figure out 10 cubed is 1,000, we can write the same number. This number here, which is a nice exponential form, is a more elegant form, but this is the way we express it using fourth roots. Much uglier, but has the same value. Using a similar skill set, 6b to the negative 4/3 is 1 over 6b to the positive 4/3, which is 1 over 6b to the fourth power to the 1/3 power, which 1/3 translates to cube root, and then we do another power of a product, and we simplify. I'm going to show you how to check in just a moment, but the reverse of that skill is you could be given an expression in radical form, and we want to be able to express it in exponential form. This is much more straightforward. The square root of v is v to the 1/2. And I said that's number 7, but apparently that's number 8, so I've got issues. But square root of 5a is 5a to the 1/2. Whoa, got ahead of myself. You'll notice I put the 5a in parentheses. If you don't do that, it's going to be 5 times a to the 1/2, which is not equivalent. So I didn't check that on Desmos because I'm an expert, but it's important that you keep the parentheses there. Alright, so the second skill is something that if you are learning what algebra is, you should not have any difficulty with this at all. But if you're still intimidated by numbers and you're intimidated by the unknown, then you see something like this and you might go into a panic attack. I would urge you to just calm down and just kind of follow the rules, because the rules are the rules and they're unchangeable. So to show you what I mean, we have this massive expression of garbage, and my job is to clean it up. So what I'm going to do is observe common bases, and in the numerator there are no bases in common, but there are x's in the numerator and denominator, and there are y's in the numerator and denominator. Before I start using quotient rule, though, to clean those up, I observe that in the denominator, I have an x here and an x there, so I can combine those into one x term, and same thing with the y's. So my first step is to use the commutative property, where I rearrange the order of all the numbers in the denominator. That way I can use the product rule here, where we add the exponents. Notice that I do not get intimidated by the fact that this exponent is negative, nor that it is a fraction. It's just a number, and all numbers are treated the same under the rules of algebra, all real numbers. So if I say x to the negative 5/4 times x to the positive 1, that's x to the negative 5/4 plus 1. It's the product rule. Right over here, I have the product rule again, negative 5/3 plus a half, but I've changed them into sixth denominators so that I can add them eventually. So I just did 2 steps in one there. But notice, product rule for the x's, product rule for the y's. Simplifying the denominator, now I have x's and y's to simplify. So there I'm going to use the quotient rule. And so instead of having x to the negative 2 over x to the negative 1/4, I'm going to have it x to the negative 2 minus negative 1/4. It's important that you show that extra step there so you don't mistake your negatives. In the 5/3, I changed to 10/6 minus negative 7/6, and that is essentially adding. So basic arithmetic here. Now I have these exponents. I'm almost done. The instructions you'll see in the assignment are no negative exponents should be left in your results. So this negative exponent means the x base is in the wrong place. So the 2 and the y to the 17/6, that's all good. keep that in the numerator. We'll send the x to a denominator and keep the exponent positive 7/4. So the point of showing you this exercise is to demonstrate, hopefully, that the work that you did prior to this, when we had exponents that were a little bit more friendly, those rules have not changed, and the work has not changed. It's just the type of number you're dealing with is a little bit more abstract, I guess. But anyway, checking using Desmos, just remember that x and y is not an effective way. You want to use different letters, A and B I did here, to show that my answer here matches the given expression for all values of A and B. So I can change these sliders, and these two numbers will remain the same. So thanks for watching. Have a great day.